So, in part 8 we looked at factorising in quadratic expressions. And I left you with this puzzle. So how does this expression factorise? Well, let me give you a clue. How many x's are there in this expression? And I don't mean how many x squareds are there, I mean how many x's are there? There are none. So how do we factorise this expression? Well, let's look at our normal rule. A pair of numbers multiply to make -9. What do they add to make? They add to make 0. So, 1 and -9, 3 and -3, 9 and -1. There's a pair that makes 0. So we get x plus 3 and x minus 3. We had no x term. We had 9, and we've got plus 3 and minus 3. So what do you think is going to happen when I give you x squared minus 16? Well, remember it's got no x's, so 1 and minus 16, 2 and minus 8, 4 and minus 4, 8 and minus 2, 16 and minus 1. And there's our pair that add to make 0. Hopefully the result you've just received there is not surprising. Now this is a special one because it allows you to work out lots of others very quickly. I'm hoping that some of you can work out that one now straight away. Well done if you did. Good. Now, this method is something a little bit special, and we call these something special. Look at 9, 16, 36 and 100. What kind of numbers are they all? I'll give you a clue. 3 times 3, 4 times 4, 6 times 6, 10 times 10. So they're all square numbers. So they could have been written like this. Now, what is the difference between 7 and 2? Hopefully you'll say 5. But then you'll think, why did he ask that? What does difference actually mean? Well, you did subtract. These four fall under a special format. Difference of 1, 2, 2 squares. Difference of 2 squares, which is where you take something like this and you can straight away factorise it because you see it as that. Let's try and write this in algebra now, this difference of 2 squares. It would be a number squared take away a number squared goes into 2 brackets. How? So hopefully you said that's a and a from the a squared, and then you may have said plus b and minus b. And this is an important result that allows us to work out lots of additional sums very quickly. Now we can also use it in this situation. This is a difference of 2 squares. What is squared here? You can see x has been squared, but I need to write this as something where everything is squared. So it's 2x, because 2 squared is 4 and x squared makes x squared. 9y squared gives me 3y. So that gives me 2x plus 3y and 2x minus 3y. Let's look at another one similar. Again, it must always be a difference, not an add, difference of 2 squares. So 4d and 5e. So we get 4d plus 5e and 4d minus 5e. This also works with fractions. And it can work with higher powers as well, as long as you're careful. Well done if you spotted that's a half x. Half multiplied by a half is a quarter. And a quarter multiplied by a quarter makes a 16th. What about y to the 4? If you remember your rules of indices, you'll need to put y squared there. Because y squared squared is y squared times y squared, which is y to the 4. So that's equal to half x plus a quarter of y squared and half x minus a quarter of y squared. So difference of 2 squares allows us to factorise a range of expressions in some ideal situations. We just have to spot it in the first place. If you remember before, in the first video for factorising, we looked at factorising a quadratic expression like this, which went into 1 bracket. We then talked about quadratic expressions like this, that went into 2 brackets. Now we've looked at one where the only other term other than the x squared, so here it's just an x, but here is a number, it has to be negative, and now we can factorise those. tricky part to come in the next part is factorising a quadratic where the first term in our expression is not just an x squared, but it's perhaps a 2x squared or a 4x squared. So watch the next part to see how to do that.